What's up, guys? My name is Ritvik. Today we're going to be working on Leetcode problem 1877. Minimize maximum pair sum in array. It's pretty high. It's pretty high of a question for what it's actually worth. This is a pretty commonly asked question in interviews, so that's why I chose to go out and do it for my very first YouTube video. So yeah, let's get into it. So basically, let's just read the problem description real quick. The pair sum of a pair AB is equal to A plus B. So if you read through the problem description, you can basically infer the fact that all we're trying to do right now is that we're trying to group each element in the array into a pair and then compute all possible subsets of pairs so that we can compute the smallest possible maximum, if that makes sense. And I'll get into it. And I know, so for example, let's take the example right here. We have 3 and 3, 5, 2, 3, right? So the elements can be paired up in pairs 3, 3, and 5, 2. So obviously we can also pair this into 3, 5, 5, 3, and 3, 2, right? And then that way the max would be 8. We're not minimizing the maximum pair in this case. So what we're trying to do is that we're trying to find the minimum possible maximum pair, right? So I know, just kicking this problem off, a lot of you guys might think that this has the semantics of a dynamic programming question where it might be like memoization, where we have to compute every possible subset or every possible group of subsets in this array to actually find out the minimum pair sum, right? That's not actually true. And this is what I say when a lot of people find that a lot of Leetcode mediums end up being easier than some Leetcode easies, because Leetcode easies are meant to like demonstrate a one-on-one mapping of a topic to the solution, right? Leetcode mediums, you kind of have to, kind of get creative with things, find a unique approach to the problem. So that's what this is a sorting question, if you guys haven't realized by now, and I'll explain why. But once you figure out that this is a sorting question, you guys are going to have like 80% of the solution done. In this case, maybe like basically the whole solution, right? So yeah, let's get into it. Let's just sort. So first, let's visualize how sorting can actually benefit us in this case. We have 2, 3, 5, 2, 3, 3, 5. My bad, I'm blind. And so obviously we can see that in order to sorting benefits us in this case, in that we're counteracting the biggest element with the smallest element in the array, right? So obviously we're pairing 5 together with 2 and 3 together with 3. And you guys might be asking, without sorting, like how are you gonna keep track of the biggest numbers, smallest numbers? I guess you could technically iterate through the array in like n-squared solution, use like a hash set to keep track of what indexes have already been accessed. We don't need any of that with sorting. So we're just going to use it. We're going to start off with arrays.sort. We know that this is a void function, so it's not going to return anything. Then we're going to want to initialize our max pair. We just call that max pair for some more clarity, or a max sum. Yeah, max pair, max sum, whatever. And then, so we just sorted this. And so let's see, like, semantically how we're going to go about trying to figure out. We can kind of see a pattern beginning to unravel right here that we see. We have 2 pointers. 5, 2, and then we're going to take this off 3, 3, right? Maybe let's take a bigger example to clarify this. We're going to take this array, and then we're going to take 2, 3, 4, 4, 5, 6, right? So obviously 6 is going to get paired with 2, 5 is going to get paired with 3, 4, 4. Now our maximum sum is always, it's going to be 8, but we could also figure out, if we didn't do that, we could do 6 and 5. That's going to give us 11, right? So our maximum sum, our maximum pair is going to be computed when we sort the array, right? So we can see that this problem has basically dumbed down into a simple 2 pointers approach. So we can do that. We can begin by initializing our 2 pointers. Our A pointer is going to be, this is generally the rule of thumb in a 2 pointers approach. Obviously, we're going to have our A pointer and B pointer. It's going to be 0. Our B pointer is going to be the length of the array minus 1. I can't spell. All right. And now we're going to do a while loop, which is another boilerplate, piece of code in our 2 pointers approach. We're going to do it while our B pointer is greater than or equal to our A pointer. We're going to update our max. We're going to make sure that our max is the maximum of our current max and the sum of the A pointer and the B pointer. We want to make sure that at every single iteration, the A pointer and B pointer are both changing by 1. So we're going to do this. A pointer plus plus, B pointer minus minus, like that, right? And that's as easy as it's a pretty simple Leetcode medium. This might be one of the easier Leetcode mediums of the easiest Leetcode medium I've done, but all we got to do is return max, and unless I've made some silly mistake, this should run. Let's try this. Cannot find symbol. Oh, that's because I called it max sum. Just call this max. Lazy. Yeah, that's it. Now let's try submitting it. That's easy. That beats 87.56%. And yeah, let me just analyze this real quick. This runs in mlog time complexity, obviously. Generally, in Leetcode problems, as long as it's not greater than mlog n time complexity, it's going to pass. So this is mlog n. It's also a sorting question, and we can confirm that if you want to like filter Leetcode questions by topics, you're like, I'm struggling on a topic, I want to get better at one of them. All you got to do is click down on related topics. You see that this is sorting, right? Or greedy, 2 pointers. Yeah, it's as easy as that. So that's gonna be the first. This is my first video. I'm gonna try to upload like twice a day, right? Because I'm basically walking through my grind 75 plan. I'm gonna be like streaming these questions as I try them out. So yeah, stay posted. Oh.